Welcome. We're going to be moving into our next unit, which will focus on quadratics. And we're going to begin by talking about the features that you have in a quadratic graph. So the first one that we have is called concavity. And when you look at these two pictures for our different options on concavity, you can see that we have a concave up where the graph is opening up. This occurs if the a value in your function is positive. On the other hand, we can have concave down, which makes your graph look like a frown, and that's going to be if your a value is negative. So just like when we factor and we talk about that ax squared plus bx plus c model, we're talking about that a as your leading value. When it's positive, it's concave up, and this is where you're thinking about it looking like a smile. Again, so if a is negative, it's going to be concave down, and this is where you're thinking about it as a frown. Okay. Another important detail to think about with your quadratics is the y-intercept. We talked about y-intercept all the time with our lines, and so I'm still talking about the point where that graph crosses the y-axis. So on this graph, we can see that happens 1, 2, 3 units above the origin. And notice that the c value in my equation, right, when we match it up, ax squared plus bx plus c is also 3. So my c value is the y-intercept. Now, a quadratic is also going to let us talk about the vertex. The vertex is always going to be an ordered pair for us. And it can happen at the minimum or maximum, depending upon if your graph is concave down or concave up. So this one is concave up. It opens upwards towards the sky. So I'm going to be looking for a minimum on this example and find the lowest spot where you have it, and then write down that ordered pair. This is at 2, -3 for that minimum. On the other hand, if your graph is concave down, like the one that we just had up above, you would be looking at a maximum value. This one doesn't have integers for its ordered pair, but it still does have a vertex. So that vertex is the turning point. It's the peak or the valley. Lastly, a quadratic has an axis of symmetry. The axis of symmetry for us is always going to be a vertical line. And remember symmetry from when you were in elementary school and you talked about where can you fold a heart in half, where can you fold a butterfly, so that both things are going to be the same. That's the same idea here. Where can you fold this graph so that the one side can fold over on top of the other side? So it's this vertical line. And remember our Hoy-Vux rules. So with that Vux, x is going to be the value that you have in your equation, and you find that by looking at the x value of our vertex. So since the vertex in this example is at 2, -3, then the x value is used in our equation. So we're talking about x equals 2 for that axis of symmetry. Okay, so on the other side of our notes here, we can go ahead and practice with some of these identification features. So here is our first graph, and we want to identify the concavity. Well, we can see that this one looks like a smile, and the wide side is up at the top, so concavity is definitely up. Also, you can see on that equation y equals x squared, so that is a positive value on x squared to tell me up as well. Looking for the y-intercept. Where does it cross that y-axis? This is happening at -3. We're looking for the vertex. Look for the low point. Write down that ordered pair. This is -1, -4. And then the axis of symmetry for it. Remember that axis of symmetry is going to go right through the vertex. So this is the line x equals -1. I want you to go ahead and try that problem off to the right. Pause the video after you think you have your answers. Come back and play again so that you can check them. Okay, welcome back. So for our concavity on this one, I hope that you notice you had a negative sign on your x squared. So that's going to indicate that we are concave down. That is why this graph opens downward with the wider side and it's frowning. When we look for the y-intercept, I hope that you found right where that crossed the y-axis. This was at +4. We can look for the vertex. Coincidentally speaking, the vertex is the same as that y-intercept here. My vertex is the ordered pair then happening at 0, 4. And when you draw that axis of symmetry through it, this is going to be at x equals 0. That axis of symmetry is right along the y-axis. So as you move down your page then, notice that these next two give me an equation, but they don't give me a graph to go with it. You're going to go ahead and create your own graph. You're going to do that right in Desmos. Okay, so given this equation, type that on in, y equals x squared plus 2x minus 8, and here we can see it. So the concavity question, as you look at it, we see that the graph opens up, so this concavity is up. The y-intercept for it, I am looking to find out where we cross the y-axis. I can click or hover on that point to get more information about it. This is happening at -8. The vertex of it, remember, it's either the high point or the low point. The low point on my graph right there, this is the bottom of the valley at -1, -9. And the axis of symmetry that we are looking for, talking about where we're going to fold that graph in half, this happens at x equals -1. Go ahead, try that problem to the right on your own, pause the video. Once you think you have your answers, come on back. Welcome back. So now that you've tried these out, let's go ahead and compare our answers, see what kind of things we got going on. So with that equation, I've plotted it into my calculator, but I can see it's a little bit big, so I may need to zoom in or zoom out in order to see the entire picture that's going on. My concavity, I can identify from the graph, or I can identify straight from the equation. I see that there's a negative coefficient on that x squared, so this is concave down. I go ahead to identify the y-intercept and look for where that graph is crossing the y-axis. A lot of times you can get a point marker on there to help you out. That y-intercept is at 24, and would you look at that? That c value again matches with the 24. Just like in the previous example, we had that -8 matching with our y-intercept. Now we're looking for the vertex to this, so go ahead and find the highest point, and it is a really, really high point on here. That's why we had to zoom out in order to see it. And so we can find that at 1, 27. Go ahead and look for that axis of symmetry. X equals 1 would be the line that you can fold this through. Remember, your graphing calculator can graph that line as well. If you wanted to check it, certainly go ahead and put it in, see if that's the line that you wanted to pretty much split that curve in half. All right, the next thing that we want to focus on is that we have a lot of vocabulary to talk about with quadratics, and it's a lot of words that all mean the same thing. We can ask you to find solutions, or we can ask you to find roots, or we can ask you to find zeros, or we can ask you to find x-intercepts. And every last one of those is just talking about where the x-intercept happens on the graph. So don't read into it too much. Just know that all of these bold words are synonyms for each other when we're talking about quadratics. So this first picture asks us to identify the x-intercepts. So I look at my graph and I figure out where it is that we cross that x-axis. So I would say that this x value is happening at -3, and that x value also happens at 1. Sometimes you'll see them listed side by side like this. Sometimes you will see them listed. Sometimes you will see them listed in a stack or more of a list. Either method's okay. When you go to the right, determine the roots of the function. Looking for roots, it purely means that you are looking for x-intercepts. Check out that graph, find your x-intercepts. So these roots, these x's, are happening at the -2 and at the +2, where we had on that graph. I want you to try out this next one here on your own. Pause the video, come back in just a moment after you have found the zeros. And so, yeah, I hope that you caught that zeros keyword. Where does it cross? Well, in this case, there's only one zero to it. The graph only touches the x-axis one time. It bounces off of it and goes back up in the other direction. This is happening at 0. And sometimes that does happen, that you might get two crossings or you may only have that one. So this next one wants me to find the solutions to the function. I don't have a graph, I have an equation. But I do happen to have a Desmos calculator that does a pretty good job of being able to line up and give us what we need to see. So I'll clear out this old stuff. And I'm talking about the function y equals x squared plus 3x plus 3. So you go ahead and graph that. I'm going to make myself a little sketch here just so that I can see this and remember. Right there's my axes. And when I made that graph, it looked like this. So if I am looking for solutions, I am clearly looking for x-intercepts. So you're asking yourself, where are the x-intercepts in that graph? Where does this cross the x-axis? It does not. This is what we're going to call no real roots. Okay. So for our purposes in Algebra 1, this graph has no roots because it does not cross the x-axis. Now, when you get into Algebra 2, you'll learn that there are actually things called imaginary roots. That's a little deeper than we need to go right now. So for right now, we're saying that it has no roots, it has no solutions. Okay, there's another one right down below it. We're going to try that one as well. Y equals a negative 3x squared minus 5x minus 3. Here's our graph. And again, if you wanted to make a sketch there with your notes, just to remind yourself what we are seeing. And it looks like our graph has a little bit of this going on. When you consider that, right, what is the x-intercept? We have no x-intercept. We have no real roots. So I hope that you understand all of these different parts about the quadratic and how many different features that these graphs have. Have a wonderful